Today we're going to talk about exponents and powers. Well, what are exponents? An easy thing to remember about exponents is it's an abbreviation. And remember, abbreviation is a shorter term or words for something else. An exponent is a number that tells how many times the base is used as a factor. For example, here we have 5, and then we have a tiny 3 that's pushed a little bit up. Well, the 5 is the base, the 3 is the exponent, and so it tells me I'm going to multiply 5 3 times. So 5 times 5 times 5, and 5 times 5 is 25. 25 times 5 is 125. Let's review some vocabulary. Here's another example. The 3, in this case, is the base. The base is always a number that's just written in normal size. The exponent is a smaller number, and it's pushed up a little bit, so it can tell you that there's something different here. So this is an abbreviation to tell me that I need to use the 3 4 times. And I'm going to multiply all of those to get my answer. So let's review though and put these in your notes for vocabulary. The 3 is the base, and that's the number used as a factor. Remember, in multiplication, what we multiply together are called factors. The 4 is the exponent, and that tells you how many times you're going to multiply that factor. Here are some other examples. In the first one, I see that the base is 6 because that's what we're multiplying. Now, how many 6's do I have? 4. So I make the exponent smaller and I move it up a little bit. We say 6 to the 4th power. Our second example, what is the base? If you said 7, good job. Now the exponent's going to tell us how many times we're using that base. And in this case, we're using it 3 times. We say 7 to the 3rd power. There is another way to say this one. It's to say 7 cubed. We can go over why it's 7 cubed in class tomorrow. Let's look at our last example. The base here is 11. The exponent tells me how many 11s I'm going to multiply. And in this case, 2. The way we say this is 11 to the 2nd power. Like the example above, there's another way to say this one, and it's 11 squared. The exponent is 3 or the exponent is 2. Those are the only ones that have a special way of saying them. Here we have some guided practice. It says to evaluate each expression using the magic tunnel. So, looking at the first one, I have 3 to the 3rd power. Well, I know that I'm going to be multiplying 3's because that's my base. How many 3's do I need? I need 3 of them. So 3 times 3 times 3, except 3 times 3 times 3 doesn't equal 81. 3 times 3 is 9, times 3 equals 27. Let's try the next one. This one can be read as 4 squared or 4 to the 2nd power. Either one is correct. I know I'm going to be multiplying 4's. How many do I need? 2. And we know that 4 times 4 is 16. The last one is 2 to the 4th power. Well, I know I'm multiplying 2's. How many 2's do I need? You're right, 4. So 2 times 2 times 2, and that makes it 2 times 2 is 4. Another 2 times 2 is 4. And 4 times 4 is 16. Now with the powers of 10, they actually are quite fun because they have some patterns. Let's look here. 10 to the first power means I have one 10, so that's going to be 10. 10 to the second power means I have two 10's that I'm multiplying, and 10 times 10 is 100. 10 to the third power, 10 times 10 times 10, and that is 1,000. Are you seeing a pattern? 10 to the fourth power is 10 times 10 times 10 times 10, and that answer is 10,000. Write down any pattern that you see so we can discuss it in class tomorrow. Let's solve these problems for some guided practice using the powers of 10. 3 times 10 to the third power, or 10 cubed. This means I need 10 times 10 times 10, which I know is 1,000. So 3 times 1,000 equals 3,000. How about 10 to the fourth power? That means I need 4 10's, which I know is 10,000. So 7 times 10,000 equals 70,000. 10 to the first power is just 10, so 9 times 10 is 90. How about 10 to the second power? If you said 100, you're great. Good job. So that would be 1,500. And 10 to the third power, I already told you 10 to the third power was 1,000, so it would be 389,000. Here's your independent practice. Please write these 6 problems down and evaluate them, meaning that I need an answer. Okay? It would help if you actually wrote the factors out also and bring them back to class.